Welcome to the video on completing bacteriological sample siting plans for small water systems. Before we begin completing the bacteriological sample siting plan, we want to answer two questions. One, what is a bacteriological sample siting plan? And two, why do we have to have a bacteriological sample siting plan? A bacteriological sample siting plan is a plan that identifies specific bacteriological sample points within a water system. We need a bacteriological sample siting plan for a few reasons. One, it is required in regulation. Two, it ensures that the water system is collecting the correct number of samples that represent the distribution system. And three, it allows the water system and regulators to adequately assess and develop responses to address bacteriological issues that may present themselves in the distribution system. The bacteriological sample siting plan is made up of two components. One, a map of the water system, and two, a form that identifies the sampling points within the distribution system. Prior to viewing this video, you should have received a guidance for completing bacteriological sample siting plans. At the end of that guidance is a form that looks similar to the one on the screen you see in front of you. A digital copy of this form can also be provided by the district office. Let's begin by completing the bacteriological sample siting plan for our water system. What you want to begin with is your system number. In this example, our system number is 5400123. In the system name field, put in your water system name. Our example system is Del Boca Vista Mutual Water Company. In the Public Water System Classification field, you need to identify what public water system classification your water system is: a community water system, a non-transient non-community water system, or a transient non-community water system. In this example, our water system is a community water system. The number of daily users, or population, is based on the public water system classification. For community water systems, you should list the residential population of your water system. For non-transient non-community water systems, you should list the regular daily population. These are the same people who visit your water system every day. An example of them would be students or employees. For transient non-community water systems, you should list the average number of daily users of your water system. For our example water system, the number of daily users, or residential population, is 285. The number of active service connections is the total number of all types of active service connections within the water system. A service connection should be considered a connection or lateral off of the water main. Connections could be homes, businesses, commercial buildings, industrial buildings, etc. For our water system, the Del Boca Vista Mutual Water Company, the total number of active service connections is 118. The sampling frequency field indicates the number of routine bacteriological samples a water system is required to take per month. This is specified in regulation and is based on the number of service connections and the population of the water system. If your water system has 400 service connections or less and a population of 1,000 people or less, your sampling frequency will be 1 sample per month. If you are unsure what your sampling frequency should be, please contact your district office. For our example, the Del Boca Vista Mutual Water Company, we are required to collect 1 routine sample per month. The list of active sources that may need to be sampled for each total coliform positive are the water system's active sources. In our example, the Del Boca Vista Mutual Water Company, active sources are well 1 and well 2. The trained sampler is the person who is collecting samples for the water system. This may be a contract operator, a laboratory, or a water system representative who is trained to collect bacteriological samples. In our example, the trained sampler is David Putty. The analyzing lab field is where we indicate the laboratory responsible for analyzing our bacteriological samples. The lab should be ELAP certified for the acceptable test methods specified in drinking water regulation. In the example, our ELAP certified analyzing laboratory is Yankee Lab. The person responsible to report coliform positive samples to the division is the water system representative. Generally, the water system representative is the person who is responsible for overseeing the operation and maintenance of the water system. For the Del Boca Vista Mutual Water Company, the water system representative is Frank Costanza. The day and evening contact number for the water system representative should be listed in the day and evening phone number field. If the water system representative has multiple contact numbers, please list all contact numbers for the water system representative. The date of the bacteriological sample siting plan is the date that we are completing the sample siting plan. Before we select our sample sites, it is important that we get a map of our water system that indicate our distribution system and our sources. In this example, we are going to use Google Earth to outline our system boundary, identify our water sources and distribution system so that we can adequately select sample points within our distribution system. Below the video, in the video description, is provided a link to Google Earth. You can go to that link and download the Google Earth application and create a map of your water system. Now that we have downloaded Google Earth, we are going to use it to locate our water system, draw our system boundaries, locate our sources, and draw our distribution system. Once we have zoomed into our water system area, we want to reset the view of Google Earth. You can do this by selecting View, Reset, Tilt, and Compass. This will give us a vertical view of our water system. Now we want to create a folder for our water system. Right-click on Temporary Places, select Add, and Folder. Here, you're going to name the folder your water system name. In this case, it's Del Boca Vista Mutual Water Company. Once we have created the folder, all the other things we add to Google Earth will be placed in this folder. Now we are going to add our system boundary. Go up to the icon, Add a Polygon. When the window opens, enter System Boundary in the name. For the style and the color, we are going to select orange for the line and orange for the area and the fill. However, the opacity of the area we will set at 30% so that we can identify locations within our water system. Once we have set these, we can begin drawing our water system. As we are drawing our system boundary, it may be necessary to move the information box to access points of our water system. You may move the box and continue drawing the water system boundary. After we have completed the system boundary, we can hit OK on the information box. Now we are going to add our distribution system. Go up to the icon and select Add a Path. In the name field, type in Water Mains or Distribution System. For the style and color, you want to select blue and increase the width of the line to 3 or 4. In this example, we are going to select 3. If you happen to select OK and close the information box, you need to go to the water mains on the left side of the screen, select Get Info or Properties, and that will open up and allow you to draw the water mains. Once we've opened up the information box again, we will begin drawing our water mains for the water system. You will do this by clicking down the roads where your water mains are located. When drawing a line that is about to intersect a line that has already been drawn, I find it beneficial to put the point just shy of where I'd like it to intersect. And then I grab that node and drag it to the line that has already been drawn. Now that we have completed our distribution system, we can select OK in the information box. Now we are going to locate our water system sources. Go up to the pin icon, select it. In the information box, type in the name of the source you are locating, in this case, well 1. Tap the icon and select the blue dot at a scale of 1 and then click OK. Now we can drag the pin to the location of well 1. Once we have done that, we hit OK in the information box. We're going to follow the same steps to locate well number 2. Now we need to complete the bacteriological sample siting plan. by selecting routine and repeat sample point locations within the distribution system. For water systems that do not have dedicated sample taps within the distribution system, it is important that you work with property owners to ensure that you have adequate access to outside hose bibs for sampling. For this water system, our one routine sample site, or one ROU, is going to be at a hose bib sample point. The location will be representative of the distribution system at the address 124 Kramer Avenue. The months that we will be collecting samples for this location is January through December. For our water system, it is the same sample site every month. Now let's return to Google Earth and locate our one ROU sample point on the map. To place the pin on the map, we select Add a Pin. In the name of the pin, we will name it 1ROU. We will change the pin type to green and set the scale to 1. Now we can place the pin at the location of 124 Kramer Avenue. This location coincides with the address location we filled in on the bacteriological sample siting plan. Once we have placed the pin, select OK in the information box. Now we need to identify our first repeat sample point on the bacteriological sample siting plan form. Our first repeat sample site needs to be within 5 service connections upstream of the routine sample site. For our water system, we identified 129 Kramer Avenue as our first repeat sample site. We will follow the same steps to locate our one REP1 sample point on our water system map. Our second repeat sample site needs to be within 5 service connections downstream of our first routine sample site. Our second repeat sample point is located at 118 Kramer Avenue. We will again place this sample point, 1 REP2, on our water system map. Now we need to identify our 1 repeat 3 sample points. In this case, they will not be from the distribution system. To comply with groundwater rule, we are selecting to sample our sources, well 1 and 2, as our repeat sample points. To identify the sources as our 1 REP3 sample points on the map, we are going to right-click the source name on the left side of the screen, go down to Properties or Get Info, and modify the source name. In this case, I put parentheses 1-REP3, closed parentheses, and hit OK. You will notice that the name on the map has been changed to identify it as the 1 repeat 3 sample point. I'm going to follow the same process to change the name of well number 2. Now that we have identified our first routine sample point and its corresponding repeat sample points, we need to identify our second, third, fourth, and fifth routine sample points. These sample points should be located throughout the distribution system as an adequate representation of the entire distribution system. In the event of a positive distribution sample, the water system must collect samples from 1 through 5 ROU the following month. For the second routine sample point, we selected 341 Costanza Road. This sample point will only be sampled the month after a positive in the distribution system. For sample points 3 through 5 ROU, we will identify sample points that are representative of the distribution system. After we have completed the form with all the sample points, we will again place those locations on the water system map in Google Earth. Finally, to complete the form, we need to identify if continuous chlorination is being provided. If yes, the system is required to sample its raw water sources monthly. Now that we have completed the form, we need to print it and sign it in the signature box located in the middle of the form. Once we have signed it, we can scan it and email it to the district office. Additionally, we need to print and save our Google Map. To print, select the Water System folder, File, Print, select Screenshot of Current 3D View, select Landscape Orientation, and now you can save as a PDF or print to your printer for your file. In this example, we are not going to actually print. We just wanted to show you what the screens look like. To save the Google Earth file, right-click on the Water System folder, select Save Places As, title the file, select where you would like to save it, and what file type, KML or KMZ. Then select Save. Now that you have completed the bacteriological sample siting plan, you need to email the district a PDF of the completed form, the map, and the Google Earth KML file that you created. If you have any questions regarding your bacteriological sample siting plan or completing the bacteriological sample siting plan, please be sure to contact your district office. Thank you for watching this video on developing a bacteriological sample siting plan.